Everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and we will try to solve it together. So we are given to compare the version numbers. So you are given two version strings, version 1 and version 2, and you need to compare them. A version string would consist of revisions separated by dots. The value of the revision is the integer conversion ignoring the leading zeros. To compare the version strings, compare the revision values in the left to right order. If one of the version strings has fewer revisions, treat the missing revisions as 0. Okay. So you are given some instruction, you need to compare the two versions, whichever is the greater, you need to return the answer in that way. So if version 1 is greater, you need to return 1. If 2 is greater, you need to return -1, otherwise you need to return 0. So you have these two versions, you can check 1.2 and 1.10. You see that 1.10 is greater. This is because this is 10 in this, after the dot the second element is 10 here and the first element is a 2 here. So the 10 one is greater. So yeah, you get it to be -1. Yeah, that's all you need to understand. So I have prepared some examples in order to figure out what is the approach, and so that you just get it easy to understand. Okay, so let's try to understand that in all these four examples, which is the greatest version. Okay, so you see, you need to compare whatever is in between the dots. So you compare this 3 and 3. You see they are equal, so you cannot decide it right now. You see, compare this 56 and 56. You see they are equal, so you cannot compare this right now. And when you go to compare this 8 and 2, you see this 8 is greater, so this is the one which is the having the greater version number. So this will be your answer. Okay, so you see whether it is in version 1 or version 2, accordingly you return the answer. Okay, so 1 or -1 or 0, whatever. Okay, so you see, uh, looking at this example, what approach can it come to your mind? It can definitely come to your mind that you separate these, you split into all these numbers. So you prepare a vector for both versions. Let's say for version 1 I prepare a vector v1 which would consist of 3, 6, 8, 5, and for version 2 I will prepare another vector which will consist of 3, 5, 6, 2, 9, and I can keep a pointer I which for version 1, and I can keep another pointer j. Okay, so whatever, I can keep both I also, and I will keep iterating them unless we reach a point when they both are not equal. Okay, so at the point when they both are not equal, whichever is the greater, whichever gives me the first greater value, that will decide whether my answer is 1, -1 or 0. So in this case, let's say version 1 has the greater value, so we return 1. Okay, so I hope you do understand this approach. So this approach comes to your mind by looking at this example. Now if you see this example, if you try to see, you see that 2 and 2 are same, you cannot decide anything. 74 and 74 are same, you again cannot decide anything. You see 0, 6 and 6 are actually the same number, both are 6, so you still cannot decide anything. Now you see 2, 0 and 2 are different because this is 20 and this is 2. Okay, so you need to consider this as the greatest number, greatest version. Okay, so the thing which you are designing, okay, so these two vectors would work here also in this approach also, but you need to take care that you need to take care of that leading zeros and trailing zeros. Okay, so these things you need to take care of. So you can use a function string to integer. There is a function string to integer. So let's say you take everything which is in between two dots and just convert them to integer. So if you convert this string 20 to integer, you will get 20, and if you convert even stuffs like 06, you will get 6. Okay, you will get 6. So that's how you can do. Now if you try to think of this example 2.7.3, this is, so you see 2 is same here, 7 is also same here, 3 is also same here, and there are two leading zeros, two trailing zeros after this, but there is nothing here. Okay, so if you look at the question, to compare the version string, compare the revision values in left to right order, and if one of the version strings has fewer revisions, treat the missing revision values as 0. So you need to treat these values also 0. So if you compare it's one on one, you will observe that everything is same. So you both versions are equal here, none is greater, so you can return 0. Okay, so now you see, if you try to compare these two, you see 2, 7, 7 again, this 3 again matches. Now you see there are 3 more numbers, so instead of these 3 more numbers you need to place 3 more zeros. Okay, so you compare this 0 and this 0, again this 0 and this 0, and then again when you compare the last element you observe that this particular version 2 is greater. Since the version 2 is greater, you will return -1. Okay, so that's how you need to do. But while analyzing this case, you definitely observe one thing, that here the lengths of the vectors are not the same. Okay, so you need to make them of same length by putting extra zeros. Okay, so make them same length by putting extra zeros. That you can easily understand. So I am just writing make them same length. So you can also start with same length, right? So let's say what you do at first is that you count the number of dots in both of the strings. So let's say x dot y dot z dot a, something like this is there in your one of the versions. Okay, so you see that there are exactly 3 dots here. So you can tell that your vector will have something like this. You can initialize our vector with something like this and then keep on modifying this one-on-one values. Okay, and if let's say another version is x dot y dot z, which is smaller than this. Okay, so you see the length is 3 coming out to be here and length is 4 coming out to be here. Whichever is greater, you initialize the both of those vectors by the same value. So at the end whenever you will get the vectors, you will get it like this. For this one you will get x y z a, and for this you will get to be x y z 0. Okay, that's what you wanted, right? You want to pad the extra values, you want to pad the extra values with 0. For that you can initialize the vector with the maximum of this. Okay, so among both the version you calculate the maximum one which has the greater number of slots. Okay, max slots. So you can just calculate the max slots of this v1 and v2 and initialize a vector of zeros, and then after that you can simply compare. You can simply keep on comparing. You can split it. Okay, so if you are using Python, definitely you can use the split function. There is dot split function. Okay, if you are using Python, that will be very convenient, but I will use C++ only. Okay, so I will show you how to do that. So what is the thing that you need to do initially is that you need some n. Okay, that n will be the length of this vector which you need to initialize. So I will write a function slots, let's say. First of all I will take the maximum of the slots of this version 1. Okay, and the maximum of the slots of this version 2, and I will simply calculate which version is having the greater number of slots. Okay, so I hope you can write a function easily. So you try to write this function on your own. Okay, so do not see the solution and simply write the function. I guess this is very simple for you. Okay, so you are given a string v, you just need to find count the number of slots. Okay, so for counting the number of slots, what you can do, you can just count the number of dots and increment by 1. Okay, you can do that. So what you can do is simply you traverse through every character in this string, and if you see that if this character is a dot, then you can increment your count, and at the end you return count plus 1, because that is the number of slots, number of dots plus 1. So I hope you do get what will be this n, and I can now initialize my vectors. I have to initialize 2 vectors with all zeros, right? So if you put nothing, I hope you do understand this is the way of initializing a vector with all zeros. So yeah, you do have initialized right now. Now you can write a split function. Okay, so you can write a split function which will take, let's say, this version and also take this vector and modify this vector in place. So it will take the address of this vector and then modifies the vector. So you can write a split function and just call it 2 times for both of the versions, right? So it's very simple, I guess. You can just call the split function. So it returns nothing. Okay, it simply fills this address, so it would return nothing. And I have this split function. I have this string v version. Okay, I have this string version, and I also have this vector address of this vector. Okay, so I will try to pass this version also by reference, but Yeah, it doesn't matter, but this one is matters, that you need to pass this vector by reference. Okay, so what by reference means, I am passing the address, I am modifying the vector in place instead of making something new. So what do I do right now? Okay, so you can see that I can have an 0 and I will go all the way till, let's say, version dot size. So I can keep a vector n which will just tell me version dot size, and I can just go through them. So yeah, uh, so you have this loop. So inside this loop, what you can do, you can have a string s initialized with empty, and you just iterate while you get the dot. Okay, so while you do not have the dot, you can tell it like this. Okay, so while version of I is not equals to the dot, or you see at the end also there is no dot, but the string is ending. So and you also write that while you get a dot or while the string ends. So when will the string end? When I will be equal to n. Okay, so while there is a dot and while the string does not end, what you can do is that you can keep adding one by one character into this empty string. Okay, and you can also increment your I. So once you get out of this loop, it means that you have completed, now you have completed storing whatever number is there in between two dots, or let's say the last number. Then what you do, you can convert this to integer and you can store it into this vector. So what you can do is that you can keep a vector indices equal to stoi of this string to integer. You convert this string to integer and store it in the vector index. Now definitely you need a separate variable for this index. So you can simply keep another variable ind initialized to 0. So at first you will store the first element in this vector, and then you will go on. Okay, and then you will simply go on. I hope it will automatically take care when the vector is ending, because the size of the vector has been calculated perfectly. So you see we do have the split and slot both ready, and we have splitted both of our strings into these versions. Okay, we have splitted these strings into the version numbers, a vector of version numbers. So I can simply do the job of iterating through them. Okay, so I can simply go through all the n. Okay, so I can go through all the whole vector number, and I need a single pointer because the both of the length of the vector is same. So what I can do is that if let's say what I can, if vector 1 version 1 is at some place greater than this version 2, if for the first time whenever you get this, you can simply return 1. Okay, there is no difficulty in this, there is no difficulty in this. And if you, anytime you get this version 1 to be less than this for the first time, okay, you can return -1. Otherwise if you get it all the same, you can simply return 0 at the end. Okay, so I hope it is very simple, not at all difficult to understand this code. So let's try to submit it and check if it works. Okay, so we do have some error. What does this error say? It says that terminate call after throwing an instance of invalid argument after stoi. Okay, so it is telling me that you are giving an invalid argument for this stoi. So you see this should be not equals to n. Okay, because at the point when it becomes n, we will break out from this loop, right? So yeah, let's try to run it now and check if it works or it still have some error. So you see we did get the accepted thing. Okay, so I will simply try to submit it and check if it works and what is the percentage bits. I guess it should be a good one because it's simple O of 1 solution, so O of n solution. Okay, so you see we do get 100% runtime complexity, and we have a simple O of n solution to my problem for today. Okay, so yeah, I hope you do understand how to solve this problem. Yeah, so that's all I guess. I hope this problem was not at all difficult to understand. So yeah, that's all for this video. I will meet you in the next day. Till then, thanks a lot.